Welcome back. In the last lecture, we have seen some of the limitations of classical logic in much more general way. So in this lecture, we will be talking about some of the examples which justify us to move away from the classical logics, which we lead us to consider either the extensions of classical logic or the deviations of classical logic. So we are motivated by some of the questions like is there any difference between something is necessarily the case that P, something which is possible that P, and something which is actually the case that P. That's the first question that we will be asking ourselves. And then is there any scope for sentences like this sentence is false, or is there any scope for vague predicates such as suppose if you say that Ram is tall, how do we know the truth value of that particular kind of sentence? So that particular kind of sentence which involves a vague predicate tall, so which vague predicates always come with some kind of boundaries where you cannot decide whether something is the case and something is not the case. It is not so easy like in the case of all men are mortal, Socrates is man, Socrates is mortal. So you can clearly draw a line between mortal and non-mortal. But in the case of vague predicates, which always fall in the borderline cases, which are neither true, definitely neither not true, definitely not false also. So how do we incorporate those kinds of sentences? For us, the most important thing is to distinguish between possibility of P, necessity of P, and what is actually the case that P, which triggers us to extend the classical logic with few more operators, unary operators. That is, something is necessarily the case that P, something which is possibly the case that P. So here are some of the modal sentences which classical logic fails to make any such kind of distinction. So it is like this. Most of the time we will be emphasizing a sentence with some kind of phrases like necessity. It is necessary that 2 plus 2 is equal to 4. It is absolutely false that 2 plus 2 is equal to 5, etc. So now if you take this example, if it is necessarily the case that 2 is the smallest prime number, then 2 is the smallest prime number. It is like if P is P implies P is the case, and that is considered to be the necessary. So necessity always operates over the whole conditional. So P implies P is the conditional here, and necessity operates over the whole conditional. Now in the second example, it is known that Ravi is richer than Ramesh. Rich is considered to be a vague kind of predicate. So the moment you talk about rich, the next question that comes to us is how rich he is. Is he rich, too rich, or too poor, etc. All these questions arises to us. It depends upon the context, and it changes from cultural background also. So then Ravi is richer than Ramesh. So in this case, I know that P, from that P follows. And in the third case, it is morally obligatory that you love your neighbor, then you have to love your neighbor. So in the same kind of example that we have seen in the case of 2, that is Kp implies P, if Kp is represented as necessity of P, necessity of P implies P, same kind of formula can turn out to be false in another domain where it involves some kind of moral reasoning, etc. So you ought to follow the traffic rules. That doesn't imply that you actually follow the traffic rules. For example, those who are in the case of emergency, the ambulance for example, they will be violating that particular kind of rule. They need not have to follow any traffic rule. So that means you ought to follow the traffic rules. That doesn't imply that you actually follow the traffic rule. So there is always a case where P is true and Q is false. So where lies the main problem with respect to why we are moving away from the classical, why we are doing modal logic? So there are several reasons. One such reason is that there is a dissatisfaction of the usage of this implication. So this leads to a paradox of material implication. So the paradox of material implication, in general, paradox is considered to be a valid kind of argument, but there is something which is not acceptable to us. So you have valid argument, but your conclusion is not acceptable to you. So the paradox of material implication concern some logical consequences or entailments which are considered to be valid according to the principles of logic, propositional logic here, but which contradicts our universal linguistic intuitions. It goes against our intuitions. So the paradox of material implication can be stated in this way, that a true proposition is implied by any strange kind of proposition, and when the sentence, a false proposition implies anything. So we don't want a true proposition like tautologies to come as an outcome of any kind of strange proposition or any contingent kind of proposition. So in the first case, I will not go into the details of it. I will be talking about it when I introduce strict implication. But there is a thorough dissatisfaction with the material implication that led to the development of modal logic. So the material implication is defined in this sense: P implies Q means not P or Q, or it is also defined as it is not the case that P is true and Q is false. So in the first case, if P is true, then this P is implied by Q. That means Q can be any kind of strange proposition. Suppose if 2 plus 2 is equal to 4, from that you can deduce this thing. If queen is rich, then 2 plus 2 is equal to 4. So 2 plus 2 is equal to 4 should not come as an outcome of it should not be implied by any strange kind of proposition like queen is rich or king is rich, etc. It has nothing to do with that particular kind of thing. In the same way, if the sentence, if a proposition is false, it implies anything. So that is what is happening in the case of 2. In the fourth case, from impossibility, that is from contradiction, P and not P, you can derive any kind of proposition Q. So let us see how it arises in the case of classical logic. So you have P and not P. From that you can deduce any kind of strange proposition. So now the first step is this thing, P and not P, assuming that the premises are all true. So these are all assumptions. So now using classical logic, P is already true. That means you can safely add any other kind of proposition Q. So here the idea here is that in this proof you need to ensure that each and every step is considered to be true. If P is true, not P is true, then P or Q is also going to be true. So now this is law of addition. So now 2 and 3, there is another kind of principle, valid principle, which is considered to be disjunctive syllogism, which says like this: if P or Q is the case and if Q is false, then you deduce P. You remove this Q and then what you get is P. And before that, you need to note that A implies B. This is material implication. This by definition it is not A or B, or it is same as it is not the case that A is true and B is false. So before all these things, let me just for the sake of our understanding, let me make these symbols clear. So when I write P, Q, R's, etc., these are all prepositional variables. This stands for, this chalk piece is yellow in color, Delhi is the capital of India, etc. They are all declarative sentences. Sometimes I use even capital letters also for the prepositional variables. Now there are a few other symbols that I am using. This stands for negation, half gamma. If you write like this, it is gamma, then it is like this, negation. In some textbooks it is represented as tilde, and ulta V stands for end, and this stands for R, and this stands for implies, which is considered to be material implication, and this stands for if and only if. So this is written in this sense. And there are some other symbols which I will be using in this course. So these are like this. This stands for contradiction, things which are always considered to be false. which is usually represented as bot. T means those things which are always considered to be true, they are considered to be tautologies. This is considered to be top. Plus in the modal logics we will be using two other symbols, and these are like this. This stands for these are unary operators which act on only one variable, prepositional variable. So it is considered to be necessity of P, and this stands for possibility of P. So that's all. These are the symbols that I will be using, and these are the conventions that we use. This is left parenthesis, right parenthesis, which is used only for the sake of our convenience. So now getting back to this one, what we are trying to show here is that from inconsistent kind of statement like P and not P, you can derive any strange kind of proposition Q using laws of classical logic. So these two disjunctive syllogism 2 and 3 leads to Q. So now from P and not P we have deduced Q. So now let us consider P to be it is raining and not P to be opposite of it, that is it is not raining. Then let us consider Q. Q can be something like Rahul Gandhi is the current Prime Minister of India. So any kind of strange kind of such kind of proposition you can derive from this thing. So not only that thing, you can follow the same steps, and then you can show that even not Q is also the case. So starting from P and not P, you can even derive not Q also. So this is where paraconsistent, in the case of paraconsistent logic in particular, they object to this particular kind of step. So that is, you cannot add any strange kind of proposition Q to something which is already true there. So this is the step that paraconsistent logicians will question, and that is you are questioning the soundness of the argument. So an argument can be valid, but if one of the premises is questionable or it is wrong, then your argument can be unsound. So it is in that sense this paraconsistent logician will show that this argument is unsound. So these things from impossible proposition you can derive anything, and truth is implied by any strange kind of proposition, and falsity implies anything. So these are some of the problems which we need to overcome. So in order to overcome this problem, C.I. Lewis has come up with another kind of implication, and he is of the view that implication that is used by Bertrand Russell and Whitehead in the book Principia Mathematica, and followed by that Hilbert Ackermann in their axiomatic systems, etc. Lewis is of the view that implication that is used doesn't capture what exactly mean by deduction. When Q is deduced from P, it is not just a material implication, it is something else. So we need to invoke some kind of intentional concepts to understand that thing or to capture it in a better way. So there is a thorough dissatisfaction with the material implication that led us to do this modal logics and sometimes many valued logic. So here is a simple straightforward example for a paradox of material implication. Suppose if you say that P stands for there is an oil in my coffee, exactly opposite of that one is not P, is the one which you are seeing in this slide. There is no oil in my coffee, that stands for not P. So Q stands for I like it. So now you put it in the original premise, P implies Q implies P, or not P implies something. Then yourself will see that if the sentence is false, that means not P is false, that means there is oil in my coffee, then from that you deduce this thing. So this is what follows from not Q, P implies Q follows. So another example is that if you consider P as I will play football tomorrow, and then Q happens to be the case that I break my leg today, then it's if you take the first example into consideration, P Q implies P. So now P stands for this thing, I will play football tomorrow. From this you can deduce this thing. I will play football tomorrow only when I break my leg, which is considered to be counterintuitive to us. Nobody will play football if they break their legs. So P, that is considered to be the truth, I will play football tomorrow, follows from any strange kind of proposition, that is I break my leg today. So when we take material implication into consideration, it is just the definition of that one is not P or Q, or it is not the case that P is true and Q is false. It is not referring to any causal implication or the causal connection or the relevance relation between the antecedent and the consequent of the conditional. Simple examples can be like this: if P stands for I am alive, and then Q stands for I am dead, then P. So from this it follows that if I am alive today, then it follows from I am alive follows from I am dead. It seems to be counterintuitive to us. In the same way, P, another instance of paradox of material implication is from P, not P implies Q is deduced. So if I am alive stands for P, and not P stands for if I am not alive, then Q stands for I become famous. I am not alive, but still I became famous. So all these instances lead us to look at this material implication in a totally different way. So the Lewis has come up with a strict implication to answer some of these questions, but unfortunately Lewis implication has also faced another problem, which is called as paradox of strict implication. There are other problems with respect to this material implication, that is this thing. For example, if you state these things, if the earth is flat, then today is Thursday, and in the same way, if today is Thursday, then 2 plus 2 is equal to 4. There is no connection between the antecedent and the consequent here. So therefore, if the earth is flat, then 2 plus 2 is equal to 4. There is no connection between 2 plus 2 is equal to 4 and the earth is flat, etc. And in the same way, P and not P, from inconsistent kind of statements you can derive anything. You can derive Q, and you can even derive not Q also. So all are classically true. There is another problem which lead us to look into or motivate us to look into the extensions of classical logic. So that is how to represent future contingent sentences. Suppose any statement which is referring to the future, which is definitely cannot be true, definitely not false. So they are considered to be contingent kind of statements, sometimes true, sometimes false. So these are referred as future contingent sentences. So what kind of truth value the future contingent sentences take? So that is is a problematic kind of is a problem right from Greek period onwards. But Aristotle could not come up with a formal analysis of this thing. Aristotle did talk about modal logics, particularly modal syllogisms, etc. But there is no proper formal analysis that are there. Only in the works of C.I. Lewis you will find a formal kind of argument. But although Aristotle has all these thoughts in his place, all these thoughts in his. So here is an example which is considered to be a problem in the when you talk about determinism. This is the example that is mentioned. So that is like this: a general is contemplating whether or not to give an order to attack or not. So the general reason is following. General reasons as follows. So if I give the order, then necessarily there will be a sea battle tomorrow. Sea battles were a frequent phenomena during those days. So if you give order for an attack, everyone obeys that order. Of course, there will necessarily be a sea battle tomorrow. If the general does not give a sea battle, that means a general who is reasoning in this way, then necessarily there will not be anyone tomorrow. If I do not give the order, then there will not be any battle tomorrow, sea battle tomorrow. So now I give the order or not. There are only two choices the general has: either give the order or you don't give the order. Hence, from this it follows that either it is necessary that there is a sea battle tomorrow, or it is also necessary that no such kind of thing occurs there. So if it is necessary that there is a C battle tomorrow, and if it is necessary that none of the such kind of things occurs, then the conclusion will be like this. The conclusion is that either it is inevitable that there is a sea battle tomorrow, or it is inevitable that there is no battle. So beforehand he knows that it is necessarily the case that there is a sea battle tomorrow, and it is also necessary that there will not be no such kind of battle. This is a conclusion which is obviously known to him before even considering all the things. So why should the general bother about giving such kind of order? So the problem here is that if you take a law of excluded middle, P or not P, it will be difficult for us to understand this problem here. So these are considered to be future contingent sentences. There will be a sea battle tomorrow. That means since it is referring to the future, so it is a contingent kind of sentence, because it cannot be definitely false or definitely true. Need not be necessarily true, need not be necessarily false also. So now according to the excluded middle, law of excluded middle, one excludes the other possibility, either P is the case or not P is the case. It seems that exactly one of these must be true. If there is a sea battle tomorrow, obviously the other thing is ruled out, that is no sea battle is ruled out. But if one is now true, that means currently whatever, if you are making such kind of statement now that there will be sea battle tomorrow, that means the sentence is true now. Then obviously there must be a sea battle tomorrow. It cannot happen that there will not be any sea battle tomorrow. If it is true now, it is true tomorrow also, and there cannot fail to be a sea battle tomorrow. The sea battle should occur at any cost. So the result according to this puzzle is that nothing is possible except what actually happens. So that means there are no unactualized possibilities. Whatever happens happens. Whatever doesn't happen anyway. So that's the reason why we say that it's our fate that something happened, etc. So there is no choice here, that we choose certain kinds of actions, etc. So now the problem here is that if something is true now, it has to be necessarily true in the future. For example, if you say that let us say that you booked your ticket, and then you will state a proposition like this: I will be in my native place and so and so time. You booked your ticket after the exams, and then you will be in your native place. So now if you make that sentence true now, there is no way in which you can make that sentence false. So it is going to be necessarily true. Something is true, it makes it necessarily true. If it is false, that means if it was true some 10,000 years ago and there would be a sea battle tomorrow, then its truth was just a matter of, it's a fact about the past, and if the past is now unchangeable, then so is the truth value of the past utterance. You cannot change the utterance of the past. So thus it is necessarily true that there will be a sea battle tomorrow. So if you say if you talk about future contingent sentence, and then you are still working in the classical logic, for example, if you say that I will be in my native place and so date, so and so time. Suppose if you make that sentence true now, it has to be necessarily true, and if you make that sentence false, it is obviously false, that you will not be able to go to the native place. You rule out all the possibilities that you go to your native place. But it so happened that you booked your ticket, everything is all right, but all of a sudden you might change your plan. Those kinds of things are not possible if you take this thing into consideration. So particularly, what kind of truth value that these future contingent sentences has to take. So what is going to be the value? Definitely possibility of P, the value of possibility of P cannot be 1, it cannot be even 0. The problem with 1 and 0 is that it pushes us to two extremes. One extreme is that something has to be necessarily true, and something rule out all the possibilities, etc. It pushes us to another extreme. So this we don't want. So what kind of truth value this possibility of P take? There is another instance with which I will stop in this lecture. Another interesting paradox which arises in the case of classical logic. If you take material implication into consideration, the definition of material implication is that P implies Q is nothing but not P or Q, And here arises a famous paradox, and which led to the development of fuzzy logic. So it is what is called as Sorites paradox, which is already there in the Greeks period onwards. There were resolutions for these kind of paradoxes, but still there is no appropriate kind of adequate kind of resolution for this particular kind of paradox. So the paradox goes like this: consider a heap of sand like this. This is considered to be a heap which consists of all the sand grains, etc. Suppose if you take away one grain, solitary grain from the heap, and then that is not going to change it into non-heap, it will remain as a heap only. And for one grain of sand is not enough to make a transition into non-heap. So there several funny examples are given in the logic textbooks. For example, a person with full hair, suppose if one hair is removed and all, it's not going to make him bald. So this small minor changes will not cause us a big kind of thing. So we will not be able to recognize these kinds of changes. So if a pile of 10,000 grains of sand makes a heap, then obviously if you remove one grain from that, it is also going to be a heap. So a heap of sand is considered to be a large collection of grains, that is considered to be the premise 1, and a heap of sand minus 1 grain is also considered to be a heap, because 10,000 is considered to be a heap, 9,999 is also considered to be a heap. So the premises seems to be okay, and the argument seems to be valid because we have used modus ponens only, and the conclusion also, but the problem is that conclusion is considered to be false. In a nutshell, the argument goes like this: you started with let us say P 10,000 etc., maybe more than that. Now if P 10,000 whatever it is considered to be a heap, then P 999 is also considered to be a heap. So now this argument goes on and on like this. These two modus ponens, you will get this thing: P 999 is also considered to be a heap. So if P 999 is considered to be a heap, then something lesser than that, if you remove one grain from it, P 9998 is also considered to be a heap. Since obviously we have this P 9999 etc., again you use modus ponens, you will get this thing. So like this, you apply modus ponens 10,000 times, or n is considered to be large. Sorry, I'll write it here. N is large. Even then, it is still considered to be a heap. So in a heap of sand like this, you removed everything, but still our modus ponens rule tells us ultimately you will come across a situation where you have nothing left there, but still it is considered to be a heap. This goes against our intuition. So in this lecture we discussed about some of the important examples where classical logic fails. One particular problem which we have seen is that it fails to distinguish between P, necessity of P, and possibility of P. For example, possibility of P doesn't imply P, but from P you can imply possibility of P, and from necessity of P it leads to P, or it leads to possibility of P. All these kinds of inferences are not possible in classical logic. Another problem which we have seen is related to the problem of material implication. There is a thorough dissatisfaction with respect to the material implication that led to the development of strict implication. These are of interest to us when we look into modal logic. Another important thing which we have seen is this, that future contingent sentences. How do we represent future contingent sentences? What value the future contingent sentences take? Is it going to be 1 by 2 or 0 or 1 etc.? So definitely it cannot take value 1 and 0, because it leads us to determinism. So if there are all problems arise, if the determinism is true, then free will is possible or not. Another thing which we have seen is paradoxes, whether there is any place for vague predicates in our logics or not. So Sorites paradox is based on the material implication, and if you follow the material implication, the argument is considered to be valid. All the valid arguments, you cannot do anything away from it, only you can show that these arguments are considered to be unsound. So how do we handle this Sorites paradox? There are many valued logics which deal with the Sorites paradox. There you will be deviating from the fundamental principles, fundamental laws of logic, that is P or not P, because if you allow for degrees of truth, then you need to allow for many truth values. So these are some of the issues with respect to the classical logic, which motivates us to look into different kinds of logics, either extensions or deviations. Unfortunately, in this course we will not be dealing with the deviations like Sorites paradox, etc. Takes us to a different turn, but we will be definitely dealing with future contingent sentences. So I will stop here. Thank you.